Yeah, good evening all. Now, myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence in SR University. Yeah, today we will discuss the concept of graphs. I think everyone knows in our previous concepts. I think visited my channel. Yeah, I uploaded many videos related to data structures. So now today I want to explain graphs in detail, the basic concepts in the graphs. Right now, the graph ADT, and application overview of the graphs. Okay, here we have to discuss many examples in the graphs, right? You now move to the a graph is an abstract data type which consists of set of vertices and edges, which of set of vertices and edges. It is a consist of set of objects that are connected to each other via links. The interconnected objects are represented by points termed as vertices, and the links that connected with the vertices are called edges. So now you remember here, a graph is a combination of vertices and edges. That is represented with a graph is a pair of set V comma E. V is the vertices, V is the set of vertices, and E is the set of edges. Set of vertices and set of edges. So now this is the graph G equal to, we write like this, A, B, C, D, E, A, B, C, D, E, 6. Now we have five vertices are there. Five vertices like first vertex is the A, second vertex is B, third one is the C, fourth one is D, and in this above graph G V equal to A, B, C, D, E. And what are the edges we have? Yeah. AB is one edge, AC is another edge, B to D is another edge, C to D is edge, and D to E is another edge. In this graph, V equal to A, B, C, D, E, and E equal to AB, AC, BD, CD, and DE. Path represents a sequence of edges between the two vertices in the above graph. A, B, D, E represent a path from A to E. It is nothing but we start from A, A to B, B to D, D to E. The source equal to A, destination is E. So the path between A to E, we have two paths are there. One is this is another one path, and another path is A to C, C to D, D to E. We write like this also. Here A to B, A, B, D, and A, C, D, E. This is also path. We write like this: A to C, C to D, D to E, R. A to B, B to D, D to E. These are the path between source to destination. Now, the graphs can be categorized in two types. One is the directed graph, and another one is the undirected graph. The directed graph consists of edges that poses a direction that goes either away from a vertex or towards the vertex. Undirected graph have edges that are not direction or directed to all. Simple example, A, here I want to write A, B, C. G equal to V comma E, we write like this. V equal to A to E, and E equal to A, B, A, C, and B, C. We write. B, yeah. How it is means A, B, C. Sorry. This is the graph. There is no direction. This is the undirected graph. Same thing is there, A to B, B to C, C to D, C to A. This is the directed graph. We have a directions from one vertex to other vertex. That is called directed graph. Sometimes we have to take the both directions, right? That is a direct. Here we have a directed graph. A, C to A, observe C to A, and there is no edge from A to B. B to A, we have a edge. There is no edge from E to D, D to E, but E to D, we have a edge. C to D is there, and D to C is also there. B to E is there. Suppose now source equal to A, C, destination equal to A, 0. Now the path is C to A, C to A, but there is no path, there is no direction. Okay, there is no path from C to E. This is the directed graphing, and for example, now we have any alternative here? No. C to D is there, but D to E, no. Suppose the source is B, we assume. Source is B, destination is C, we assume. Source is B. So here we start from source. So B to E is available, direction is there, and E to D direction is there, and D to C is also there. This is the path from B to C in the directed edges. And coming to undirected edges, there is no directions between one vertex to other vertex. This is represented either A to C, or this is the A to C or C to A. This is the C to D or D to C. Okay, it means we have a both direction. There is no specific direction from one vertex to other vertex. This is the difference between directed graph and undirected graph. Okay, in directed graph, you remember we have a directions from one vertex to other vertex. And undirected graph, there is no specific edges, specific directions from one vertex to other vertex. Now we have many graphs are there. That is called the one is the weighted graph. Weighted is a graph in which each edge is assigned a numerical value. Why we use the weighted graph? Weighted graph is especially for the spanning trees, minimum spanning trees. Already in last video we discussed that is Krishkov's algorithm and Prim's algorithm. In both algorithms we have a weighted graphs. So weighted graph is a graph in which each edge is assigned a numerical value known as the weight. The weight represents the cost, distance, or any other metric that quantifies the relationship between two vertices. Okay, so now A to D, the weight to D weight is 4, and D to A weight is 1, and C to B weight is 2, 3, and A to B weight is 2. This is the weighted graph. And unweighted graph, the second graph is the unweighted graph. So unweighted graph is a graph where all edges are treated equally with no extra values like distance or cost. Directly only weight only. There is no value between one vertex to other vertex. That is called the unweighted graph, right? So the graphs can be categorized in two types. One is the directed graph, another one is the non-undirected graph. In directed graph, we have take a specific directions between one vertex to other vertex. In non-directed graph, there is no specific vertices, specific directions between one vertex to other vertex. So that is undirected graph. In weighted again, we have a undirected graph. We have the weighted graph, and directed graph also we have the weighted and unweighted graphs. Next one is the acyclic graph and cyclic graph. Acyclic is defined as a graph that contains at least one cycle, which is a path that begins and ends at the same node without passing a cyclic graph passing through any other node. So simple. Now source equal to simple here. This is source equal to destination. That is called V0 equal to Vn. That is called a cyclic graph. cyclic graph. So here we start from this one, start one. Now this is the one edge. Okay, suppose now this is one, this is two, this is three, this is four, this is five, this is five. Now we have to start with what, two to three, three to five, five to four, four to. Now what is the source here? Two is the V0 and two is the Vn. So if V0 equal to Vn, that is called the cyclic graph. Now characteristics of a cyclic graph. A cyclic graph contains one or more cycles or closed paths. A cyclic graph can be either directed or undirected. There is no specific directions. So here directions, now you start with the two and you end with the two. Cyclic graph may have multiple cycles of different lengths and shapes. A cyclic graph is a bipartite if and only if all its cycles are even in length. So these are the characteristics you observe here. A cyclic graph is defined as a graph that contains at least one cycle, which is a path that begins and ends the same node without passing through any other nodes. Okay, a cyclic graph contains one or more cycles, closed path. A cyclic graph can be either directed or undirected. A cyclic graph may have multiple cycles of the different lengths. A cyclic graph is a bipartite and it's only for all its cycles. And degree of the vertex. You observe here, it is important here. Degree, that is called degree equal to in degree plus out degree. So this is the count of edges connected to the representing its number of neighbors. Number of neighbors. Okay, in undirected graph, it's the total edges incident, while for directed graph, it splits into in degree edges coming and out degree edges going out. A vertex with degree is one is pendant and degree zero is isolated. So now B degree equal to 2, A degree equal to 2, as well as C degree equal to 2, and D degree equal to 2. Right? Now, 1 second, wait. Yeah. Now, this is the degree, okay, in degree and out degree, as well as one more is degree of sequence and degree of spectrum. Okay. Now, B degree of vertex is now the connected to it represent the number of neighbors. B neighbors. What are the neighbors of B? One is A, another one is C. And A neighbors, one is D, another one is B. C neighbors B and D. So this is called in degree of A. So now the degree B is receiving, this is the B in degree. And the degree, that is the edge going out. What are the edge going out? Now B to C, this is the out degree. So now we have to write the vertices with graph like vertex, in degree, out degree, degree, right. Now A, B, C, D. A in degree is 1. This is the in degree of A, and B out A out degree is 1. So, B is also 1, 1, 2. Now E is also 1, 1, 2, 1, 1, 2. So now degree of sequence, degree of spectrum. Degree of sequence is 2, comma 2, comma 2. If you have any less than 2, first we write like that. And degree of spectrum is written as 1 comma 1 for A, 1 in degree comma out degree, in degree comma out degree, and in degree comma out degree. This is A, this is B, this is C, and this is D. This is called the degree of sequence and degree of spectrum. So now this is the degree of the vertex. And next one is now I want to explain another graphs like uh, bipartite graph. And one more is the null graph. First of all, null graph. Okay, there is no vertices. The point one, right, like this. Now these are the vertices. So there is no edges between one vertex to other vertex. So this is called the null graph. Okay, null graph. Right. And next one is the bipartite graph. This is represented with K, 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 M, comma, N. K, M, comma, N means now we have K, M is 2, N is 3. So this can be categorized two types. One is the partial bipartite and complete bipartite. Now this vertex is connected with this one only. This is not connected this one. This is connected this one only. This is connected this one. This is connected only this one. If the graph is the above n is connected with the remaining all m, that is called the complete bipartite graph. And what is the complete graph? Complete graph is a graph which connected every vertex is connected with the remaining all vertices. So now I want to write small example here. A, B, C. A is connected with B, A is connected with C. B is connected with A and B is connected with C. So one vertex is connected with the remaining all the vertices. That is called the complete graph. In complete graph, we have written like number of edges equal to mod E equal to n into n minus 1 by 2. Number of edges are n into n minus 1 by 2. N is the V. So 3 here in this example, 3 minus 1 by 2. So 2 to cancel, number of edges are 3. A to B, B to C, and C to A. This is called the complete graph, right? And now applications vary of the graphs. Applications are, one is the social networks are made up of a people or groups and they're connected with each other, connected with the connections or interactions. These networks can represent both online communication like Facebook or Twitter, or offline ones like work groups or family. So now one node is connected with the remaining nodes. So that is called the application of the social network. Social networks are important for understanding how information, influence, and behavior spread among people. Now, social networks are important for understanding how the information is communicated with the others. And Graph 3 helps model, analyze, and understand social networks. By using graphs, we can find hidden patterns, identify important people, detect groups, and study how information spread. Okay, this is the application overview of social network. Okay, now mainly we have connected with one point is connected with the other point. That point is called the vertex. Now graph theory is great for modeling social networks because it can easily represent the connections between people. Here is why it is helpful. So representation of relationships. Graph shows how people are connected through friendships, work connections, or other interactions. So now here people is a node or verticals. Okay, now the connections or interaction with one person to other person is the edge. So simple, we have a three people. One person is communicate with other person, and other one is communicated with the first one person. So now we establish a connections between one person to other person, that is called the edges. And community detection, graph theory helps find groups of people who are more closely connected to each other than to others. So that is the graph theory help find groups of people who are more closely connected to each other than others. Influence and information spread. Social networks are important for understanding how information or behavior spread. Graphs help model these processes. And centrability measures, that is called graph theory, gives us a way to identify major people or influence in a network, such as those who are well connected or influential. So these are the application story of the network. And next one is the one second. A network routing is the process of selecting a path in a network along which data or traffic is transferred from one node, that is source, to another node destination. In the context of graph theory, the node represent entities such as routers, switches, and interconnections, and the edges represent links between them, such as a network cables or highways. The goal of routing is to ensure that data is transmitted from the source to the destination with the least cost, time, or resource. Routing algorithms decide how the travels the network by finding an optimal or near optimal path based on different criteria like a network traffic or available bandwidth and delays. So now you observe here, this is the network routing. What is the network routing? What is the topologies already? In networks, we have a topology. The topology is the physical connectivity between one node to another node, one node to another node, using with the cables or highways. So the graph applications are using in the topologies. Like we have five topologies are there. First one is the bus topology. You observe here. Now these are all the nodes connected with bus. So this is A, we assume this is B, this is C, D, and E. So now we have to transfer the data from A to E. So via bus, this is one process of transferring the data. Another one is the in topology we have a that is called hierarchical topology. This is the hierarchical topology, like tree, like tree. Now we have to transfer data from this node to this node, we assume. So now these are all the edges. These points are called the nodes or vertices. Now we have to transfer data from source to destination via the hierarchical network. And next one is the ring topology. That is called, one second. This is the ring. These are all the nodes. Now, and another one is the star topology. One second. Star topology. You observe the differences between ring topology and star topology. In ring topology, we have another alternative. So in these two examples, the first one is bus topology. If is there any node is failed, the data transmission is also failed. In hierarchical also same thing is repeated. If route is failed, then the data is not transferred to other nodes. And coming to a ring topology, we have a alternative. Suppose now this is the source and this is the destination we transfer. Now if this node is failed, then we have a alternative path. This is also application of the graph. And one more topology is the star topology. In star topology, we have to create the hub. This is the hub. Now all all vertices are connected with this hub. Okay. Now we can transfer data from one node to other node via hub. Suppose hub is failed, then there is no possibility to transfer the data from one node to other node. This is the drawback in the mesh topology. So now in graph concepts are graphs are using here, and the very important topology is the hybrid. Is the mesh topology. Mesh topology. So this is the mesh topology. So this node is connected with the remaining all. This node is connecting with the remaining all. This node is connecting with the remaining all. This node is also connecting with the remaining all. Simply, this is the complete graph. Suppose we have to transfer data from here to here. So is there any problem will be occurred? Then directly we have to choose another path, because we have a number of paths between one vertex to other vertex. So this is the application story of the routing algorithms. So now this is about the graphs introduction. Once again, I want to explain graphs. See, a graph is an abstract data type which consists of set of objects that are connected to each other via links. The interconnected objects are represented by points termed as a vertices. That is called the graph is G equal to V comma E combination of vertices and edges. Now vertex is denoted with the node, and edge is a link between one node to another node. So next one, G equal to V comma E, V equal to A to E, number of edges, and E equal to, we have here some that is the nodes are there, A to B, A to C, C to D, and B to D, and D to E. The path is the representation of sequence of edges between the two vertices, source to the destination. So the graphs can be categorized two types: directed graph and undirected graph. Okay, directed graph, we have a directions from one node to another node. Undirected graph, there is no direction. So weighted graph, we have a weights between one vertex to other vertex. So unweighted graph, no weights between one vertex to other vertex. So cyclic graph, we have a cycle, minimum one cycle in the cyclic graph, that is source equal to destination. If you want to start with A and end with A, so V0 equal to A, Vn equal to A. So that is called the cyclic graph, right? And cyclic graph, directed and undirected is also there. And next one is the degree. Already we discussed. Degree is the in degree and out degree, degree equal to in degree plus out degree. So in degree is the edges coming into the node, and out degree is the edges going out to the node. So in social networks, we have to use the different nodes. So thank you all. This is the basic concepts of our introduction to graphs. Thank you one and all. Please like this video and share to your friends. This is very valuable for BTech students particularly, and MSc. So graphs, we covered introduction to graphs, and we covered minimum spanning trees like Krishker's algorithm and Prim's algorithm. Thank you, one and all. Yeah, now the weighted graph is also completed here. And undirected graph and weighted graph. So now this is the weights between one vertex to other vertex. And next unweighted graph, there is no weights between one vertex to other vertex. So now we completed cyclic graph is defined as a graph that contains at least one cycle, which is a path that begins and ends at the same node without passing through any other node twice. So we start from here. Now we move from this node to this node and this node to this node. and this node to this node, and finally this is the source equal to destination, then that is called the cyclic graph. And another one is the acyclic graph. If source not equal to destination, that is called the acyclic graph. Okay, characteristics of the cyclic graph is a cyclic graph contains one or more cycles or closed paths. A cyclic graph can be either directed or undirected. The cyclic graph may have multiple cycles of different length and different shapes. A cyclic graph is bipartite if and only if all its cycles are even length. So the next one is the degree of the, and cyclic here we have a null graph is there, bipartite graph is there, and next one is the wheel graph is there, right? And next one is the complete graph. And complete graph means n vertices with n into n minus 1 by 2 edges. Okay, null graph, there is no edges between one vertex to another vertex. So just we have a vertices, there is no connections. And next wheel graph, it is nothing but a ring topology, star topology. Now the hub is connected with the remaining all nodes. That is called the wheel graph. Okay, we have different graphs are there already we discussed. And now degree of the each vertex, and that is in degree and out degree. Now degree equal to in degree plus out degree. So, and next one is social work, where we are using the graphs and what are the applications. Okay, mainly the graphs concepts are using in the social media as well as networks and communication channels. So, and next one more is the complete, that is called the in graphs and trees. Both are similar, but most of the times graphs are using for the network purpose. And next one is the minimum spanning trees. In one video, we discussed minimum spanning trees. Now you know the spanning tree. Spanning tree is a subgraph of graph with contains n we connected graph, and we cover the all the vertices. And next one is the next one, right? And mod e equal to mod v minus 1. And now there is no cycle. Yeah, that is called the spanning tree. We have a minimum spanning tree algorithm, Prim said, Frisch calls. Okay, this is about the uh, introduction to graphs. And next we will discuss the social media and degree of vertices alpha. Thank you. Thank you all.